Okay, in our last class we talked about polynomials and some definition of those. In this session we're going to look at adding and the nemesis of most people, subtracting polynomials. Okay, so first off, when you're adding polynomials, what you need to do is only add like terms. Last day we talked about those, and like terms are those that have the same variable and same exponent. So this one and this one would not be like terms, but this one and this one would be like terms. So when we're adding them, and I like here they're looking, this is a trinomial, 3 terms, plus another trinomial. If you're adding those, I like to first drop the brackets. So 3x squared, it might seem like a lot of work, but I like to do it. This plus means I just have to leave everything in that second bracket as it stands. And then I like to group like terms. So 3x squared, and then there's a minus 2x squared over there. There's a positive 2x. There's a 5x. There's a minus 2 here. And there's a plus 5. You sort of have to be careful, make sure all the signs go with things. So whatever the sign is out front, that's what goes with that term. And then you can simplify. And that's always when you have these kind of questions, the instructions are to simplify. So 3 minus 2, that'd be 1x squared, 2 plus 5, that'd be plus 7x, and minus 2 plus 5 would be a positive 3. So this would be my simplification of this original 2 trinomials. Notice I didn't solve for x. I'm not looking to solve an equation. All I'm doing is simplifying. Here's some other ones. Maybe try these ones on your own, and then I'll write the answers down. So you can press pause, and then once you think you've got them, press play, and we'll have them answer. I notice that this is positive. If it's positive, I can just look for like terms and get them together. Minus 4, there's no other x to the fifths, so that one stays. X to the fourth, this is the only one. Plus 7x to the fourth. X cubed, there's only one of them. X squared, there's only one. And a plain number or a constant term, there's only one. Did I get them all? 1, 2, 3, 4, 5. Yeah, there's 5. Boy, I didn't have to add like terms at all there. Here's one that maybe I will. I'm adding, so I can just drop the brackets and add like terms. So 31 take away 7 would be 24x to the fourth. X squared, here's an x cubed. Let's do that one next. So plus 5x cubed. X squared, that's the only one that they have. Then I have a 2x and a minus 2x. Those would cancel, so they're gone. And then I have minus 1 plus 2 would be a positive 1. Hopefully you got those as your answers. Again, as you're going through, sometimes it's nice to tick off the ones that you've used, just so you keep track of all the terms that you have there. Okay, so that's adding polynomials. Now let's get into subtracting, which is typically a rough thing for a lot of people. When you're subtracting polynomials and you see something like this, a negative sign out front of a bracket, I lovingly call that a dirty, rotten, filthy, stinking negative. And I didn't call it that. Steve Penny, a student a long time ago, he named it that. But they cause students lots of troubles. If you ever see a negative sign in front of a bracket, be careful. And what you need to do is, it says up here, you need to change the sign of everything that's inside the bracket. So inside the bracket here, this is a positive 4, so it would need to be changed to a negative 4x cubed. This one's a negative 6, that one changes to a positive 6x. And this one's a positive 3, it changes to a negative. Notice that I change each of them. What else was I going to say there? I think that's it. Anyway, you need to change each of those signs within there. Not just the first one, it's all of them. Try that one. Press play, press pause, then press play when you're done. You should have come up with, this is negative, so that'd be a positive 7x to the fourth. Wouldn't really need to put the positive in. minus 5x cubed plus 2x and minus 2. Notice that I changed every sign within there. Now the important thing for that is because when we're subtracting polynomials, I see that right there. Here I'm subtracting a trinomial and a binomial. If I see a subtract in front of brackets, I've got to change everything inside. So I'm going to leave the first one alone, 7x cubed plus 2x plus 4. And notice I'm doing this before I'm even looking for like terms. You have to deal with that dirty, rotten, filthy, stinking negative before you collect like terms. So this is a positive 5x cubed, so it changes to a minus 5x cubed. Notice that I'm making a distinction of something inside the bracket and something out. This is subtract. Inside there, this is a positive 5x cubed. So when I drop the brackets, it becomes a negative 5x cubed. It sort of stays there, but hopefully you get the idea. Inside there it's positive, so a minus outside forces that to be negative. If you wanted to write it as plus a negative, you could write it like that too. Typically I like to just write it as a negative like that. Okay, so I've changed the first one. Also, don't forget to change the last one. Plus 4. Now I collect like terms. And again, if you want to rewrite them so they're all together, you can do that. If you're getting so that you can just write them in your head, that works too. As long as you don't make mistakes. Okay, 7 take away 5, so I'm left with 2x cubes. There's only one x term, so plus 2x. I have two constant terms. I'll add those together. Here's some questions for you to take a shot at. Try these two, press pause and try them, and then when we're back, see if you come up with the same answer. Okay, we're back. I can't do these in my head. I have to rewrite them. 3x squared plus 5x minus 4. Leave the first one alone. Now all these inside have to change. So it's a minus, so this forces it to change to a positive 4x squared. This is a negative, or a positive, it changes to negative 11x. Negative 2 changes to positive 2. Now I can look for like terms. There's some x squareds, those will be a positive 1x squared. And then I've got an x here and an x there. Up 5, lose 11, I'd be down 6 x's. And then finally I've got a negative 4 and a positive 2. I'm down 4, I gain 2, I'm still in the hole 2. So this would be the simplification of that one. Okay, I'm going to try this next one in my head, but I don't know. It's nice to rewrite it. But, okay, minus 6, minus 2, minus 8x to the 4th. Oh, here's a 5x cubed one. Oh, shoot. I'm wanting to write plus 5x cubed there, but there's the negative side out, the negative out front there. I can't do this in my head. I'm going to rewrite it. Minus 6x to the 4th plus 3x squared plus 6. And notice when you're doing stuff like this, if you get in the habit of doing a certain thing all the time, that it helps your efficiency and it helps your accuracy. If you try and do too much stuff in your head, you're going to mess things up. Okay, so I've applied this dirty, rotten, filthy, stinking negative to each term in there. Let me just check. This is plus, now it's minus, plus, minus, minus, plus, plus, minus. Right, I'm good. So now let's simplify. This one minus this one, minus 8x to the 4th. Here's the only x cubed that I've got. A plus 3x squared plus 5x squared, that'd be a plus 8x squared. Looks like there's no x terms. So now I just have 6 take away 7 is a negative 1. Let me just make sure I've got all those. So x to the 4ths, got. X cubed, got. X squareds, got them. And the constant terms, got them. Okay? Alright, so that's subtracting polynomials. You got to be really careful with those. That thing there has caused more marks on a student's exam than anything else. Oh, and then there's fractions. Right on. Same thing with fractions. You do the whole thing. I'm not going to do this one, but I think this is one from their book, and you can check the answer there. But doing it, whether it's fractions or decimals or what have you, in a question, you do the exact same thing. Make sure you change the sign of everything inside to its opposite, and then collect like terms. All right. Here's just a simple application kind of question at the end that maybe is a way you could do it. They say find the perimeter of all these things, so 2x plus another 2x plus an x. You'd have to add all those. X plus another x plus another x plus another x. And then over here I'd have a half x on this side, x on the top, and it's just a matter of adding all those together. That's just, I guess, adding like terms, that one. Okay, so if I were you, I would grab some questions from section 4.4 and try a couple of the adding ones, and then zero in on the subtracting of polynomials. And hopefully this little scribblecast has helped you out.